Hello and welcome back to this series that I've been doing, archival data research in Matlab. And we're going to continue where I left off with in the last video. I was showing you all how to compute financial ratios in accounting. And we had this code that we had, this script file that we had worked up. And the end result looked like this. I'm running it currently. You see it says busy down here. What I'm going to do in this video, I didn't have enough time in the last video. It was already 2 hours and I didn't want to continue it. But I wanted to go back and, first of all, talk about some of the meaningless ratios and setting those equal to NaN. And then once I've done that, then compute the mean and the median of each of the ratios by fiscal year and by SIC two-digit industry, and then show you how to plot a particular ratio's mean or median over the years and over the industries. So that's what I hope to accomplish in this video. So first, thinking about the meaningless ratios, I meant to do something in the last video that I didn't do, and I should have done it right after this step before I got my final ratios. So here's our final data here. And before converting that to a table, I should have done this step, which was to set certain meaningless ratios equal to NaN. So for example, column 6, this is the current ratio. It can't be less than or equal to 0. That doesn't really make a lot of sense. I guess it could be equal to 0. If current assets is equal to 0, it could be 0. But current assets aren't going to be 0. And if there's a company whose current assets are equal to 0, well, we probably don't want them in our analysis anyway. They're not a normal company. So the current ratio can't be less than or equal to 0. The quick ratio can't be less than or equal to 0. The debt to assets ratio can't be less than or equal to 0. The debt to equity ratio, now that could be negative because equity could be negative if we had a bunch of loss years in a row and we had negative retained earnings. And the negative balance in retained earnings was greater than the positive balance in common stock. You add those together, you could have a negative balance in equity and therefore have a negative debt to equity ratio. So we won't deal with this ratio, but we will deal with these three. These three ratios can't be, they must be positive. And then this one was the gross profit ratio, and of course that's got to be less than 1. It can't be greater than or equal to 1. If it's 1, that means cost of goods sold is 0. If it's greater than 1, that means cost of goods sold somehow is negative, which doesn't make any sense. So it can get up close to 1, but it can never be 1. So we'll set any ratio here that's greater than or equal to 1 equal to NaN. And any ratio in these three columns that's less than or equal to 0 equal to NaN. So let's do that with the following 4 lines of code. So first I'll write myself a comment so we know what the following code is going to do. We're going to set meaningless ratios equal to NaN, And an example of a meaningless ratio would be where the current ratio is less than 0. That's meaningless. Doesn't make any sense. Can't happen. Current assets and current liabilities both have to be positive, so the ratio has to be positive. Or I guess to be technical, they both have to be, numerator and denominator both have to be non-negative, so the ratio has to be non-negative, but I'm going to also disallow 0. So we're going to find those rows of final ratios data which are less than or equal to 0. In column 6. And we're going to set that equal to NaN. So these rows of final data, column 6 is the current ratio column. So these rows of final data, And what are these rows? These are the rows in the final ratios data column 6 that are less than or equal to 0. These are the row numbers. Right? Logical indexing. We taught you that last video and the video before that. Logical indexing will get you a long way in Matlab. So these rows of final ratios data column 6, set it equal to nan. And then what I can do is copy and paste this line down 4 times. Column 7 as well. That was the quick ratio column. Column 8 was the debt to assets ratio column. Oh, I did this too many times. Column 9 is debt to equity. Now that could be negative, but column 10 was the gross profit ratio, and that cannot be greater than or equal to 1. So let's just change these comments really quickly. All right, so let's run this. And that set the certain portions of final ratios data equal to nan that we needed to set. And then we can convert it to our table, our ratios table. All right, now what we're going to do next in our code, and I meant for this to go down one more line. What we're going to do next here is, like I said, we're going to compute the mean and the median of each ratio by both fiscal year and SIC 2-digit industry. Now, in doing this, I'm not going to be looking at any outliers or trying to remove any outliers before computing these means and medians. And therefore, the means are going to be affected by outliers, and it may look a little wonky. It's because I'm not trying to do anything with outliers before doing this. Now, typically, you would want to deal with outliers before doing this. But this video is not about how to deal with outliers in accounting research or finance research. That's a whole nother topic of its own. So I'm not even going to deal with outliers in this video. So what I'm going to do is I want to convert, I'm going to set the double portion of our ratios table equal to R, so that'll be a double array. R will be a double array. And the reason I want to do that is because it's easier, it's faster computing in Matlab when you're working with a double array than a table array. The same reason I did it up here. Once I had my initial data table here, then I converted. I mean, I left that a table, right? It's still a table right here. But then I defined this double array for faster computations, and I worked with A, the double array part, not the table, but the double array. I worked with A from then on. Faster computations. Like I've said this already, so I'm just repeating myself. Same thing here. We have our ratios table, but I'm not going to work with the ratios table. I'm going to define the double portion of the table. So all the stuff in the table, not including the column headers, this, define that as R, or let R be defined as that, and then work with R. So let's run that. So here's R. We don't have our column headers anymore. And now what I want to do is I want to get the SIC 2-digit industry. We want to compute the mean of all these ratios, of all these columns, by fiscal year and by SIC 2-digit industry. We don't have SIC 2-digit industry. We only have the 4-digit industry here. So we need column 2. We need the first 2 digits of column 2. So let me just type some code to see how this would work. How do we get the first 2 digits of column 2? Let's just take one of the elements, 5080. If we take 5080, we divide it by 100, we get this number. And if we take the floor of that number, which means it rounds the floor of a given thing in Matlab, the floor function, it takes that number and it rounds it down to the next integer. It rounds it down to the integer that's I don't know how to say it. It just rounds it down to the next integer. So this would be rounded down to 50. Floor of answer would be 50. And then the function ceiling would round this up to the next integer. It would round it up to 51. So that means if we take floor of R, all rows column 2, divide by 100. So what that will do, R all rows column 2 is a column vector divided by a scalar 100. So each element of this column vector will be divided by 100. And so this is a column vector. This is a column vector of numbers. And then we take the floor of each of those numbers, then we'll have the first 2 digits of this column. So that's what we're wanting to do in general. So what I'm going to do is I'm going to redefine R. I'm going to let R equal what R currently is, columns 1 through 2, GV key 4-digit industry. But column 3 of the new R, I want to be the first 2 digits of column 2 of the old R. And we just said how to do that. This way. Column 4 of the new R will just be columns 3 through the end of the old R. All rows. So we're adding 2-digit SIC code as a variable to the data. So basically R is now going to look like it does here, except between columns 2 and 3 we'll have another column with the 2-digit SIC code. And there we go. So now our R, which used to have 14 columns, has 15 columns because we've added this column in the middle. All right, now let's compute. Let's first do it by year. So compute the mean and median of each ratio by fiscal year, by the fiscal year variable, which is in column 4 right now. This is the fiscal year. So we first need a list of all of the fiscal years. So I'm going to let this little matrix, I'm going to call it years, equal the unique fiscal years. The fiscal years are in column 4. So this function here, unique, just pulls out the unique values in this little matrix or array. And this is a column vector, right? All rows column 4. This is the year column. So we're pulling out the unique values. So let's run this. And there are 12 unique fiscal years. Now our sample covers the calendar time period January of 2014 through December of 2023. But since our sample includes non-1231 fiscal year end firms, it includes any firm, no matter if it's fiscal year end aligns with the calendar year end or not, then you're going to have fiscal years 2013 and 2024 in there as well. So there'd be 12 fiscal years covered. And that's fine. We're only dealing with Compustat data in this video. And Compustat's just based on fiscal year. It's only whenever we want to merge Compustat data with data that's not based on fiscal year, that's based on calendar time period, then that's when we have to really understand this difference between fiscal year and calendar year. Like when we merge Compustat data with CRISP data and try to get the stock returns, the daily or the monthly stock returns. That's when that will make a difference. But when we're just using Compustat data, we really don't have to get bogged down into all the fiscal year stuff. But we will do that in a future video. We'll go back and explain exactly. Go back here to our initial data. Exactly. We'll do a practice where we'll explain exactly what does fiscal year end month mean. If the fiscal year end month is 1 through 5, then so this fiscal year, it starts its fiscal this row right here. This company starts its fiscal year on January 1st of 2013, and it ends its fiscal year on May 31st, month 5, May 31st, 2014, and it's given a fiscal year of 2013 in here because the majority of its fiscal year lies in the calendar year 2013. If this was a 6 here, then it would start its fiscal year in on June 1st of 2013 and would end its fiscal year on it would start its fiscal year on July 1st, of a given year, and it would end its fiscal year on June 30th of the next year, and it would still be given this fiscal year of 2013. In that case, 6 of the 12 months were in 2013 and 6 of the 12 were in 2014, and so it would just give it the 2013 fiscal year. But if this was 7 or greater, actually I think it has to be 6 or greater, and then it gives it the next year. If it was 7 or greater, then clearly more of its fiscal year would align in calendar 2014 than in calendar 2013, and this would say 2014. But we'll get into all those details later, and that will matter later. All right. So now we have our unique fiscal years, and now we can compute the mean and the median ratios. So we're going to use a for loop. So for I equals 1, starting at 1, incrementing by 1, and we want it to go all the way up to how many ever years there are. So the size function will tell us that. The size of the years vector and the size of the years matrix in the row dimension, which will be 12. So I will go from 1, increment by 1 each time, up to 12. And then we'll have our mean. I'm going to call this the mean ratios by year matrix. Row I, column 1, row I, all columns, will be equal to, the first column will be whatever the years row I, column 1 is. So like when I equals 1, it'll be 2013. And then over here will be all the means of each of the ratio columns. The NaN means, not counting NaN values. So the NaN mean of R, all rows. Oh, careful. The NaN mean of R, but which rows of R? We know what columns of R. It's going to be columns 7 through end. But which rows of R? It's these columns of R, right? Current ratio, quick ratio, debt to assets, debt to equity. Can't remember what this is. I'd have to go back and look in the initial data. But we want the mean of columns 7 through 15, but only the rows which correspond to fiscal year 2013, right? So only those rows where years I1 equals are all rows column 4. So these rows of R, column 7 through end, are the rows with which we want to compute the NaN mean. These rows of R. Column 4 is the fiscal year column, so we're 2013. Which row numbers of R do you find 2013 in column 4? And it's only those row numbers that we want to compute the NaN mean of these variables. Median ratios by year row I, all columns. And we can just copy and paste. And change this to median. And then run that. There are the mean ratios by year. There are the median ratios by year. And then we can, next thing I want to do is show you how to plot. So we'll plot, say, one of the ratios. Plot the mean and the median of, let's pick one of the ratios, return on assets by year. And then I'm going to type a command or a comment to myself here. Notice the median is about 0 each year. You'll see this from the plot. And the mean is negative each year. Now it is true, like I said before, that outliers are heavily influencing the mean, and we may want to deal with these outliers before making a plot, but we're not going to do that in this video, but I'm just typing that to myself. So how do we make a plot? Well, if we want to make a line plot, we type figure. That's what I'm going to teach you how to do in this video, a line plot. Then the plot function. Now it has multiple arguments. What we want on the x-axis is the first argument, so years, all rows, column 1. What we want on the y-axis, we want the mean ratios by year, all rows, column, whatever the return on assets column is, which I believe is column 8. So that's what we want to be plotted on this plot, but we also want the median to be plotted. Now this argument here is going to be, well, I won't put an argument there for now, or I won't do what I was going to do, and then I'll change it later so you can see, you can compare and contrast. All right, then we want on the x-axis the years, all rows, column 1, and we want to plot the median on the y-axis, the median ratios by year. So we want 2 lines on this plot, all rows, column 8. So this is the mean ROA and the median ROA plotted on the same plot by year. X-axis, we want to be labeled the following year. We want the font size of that label to be 14. That's typically what I do. Semicolon. Y-axis, we want it to be named, we want the title to just be average return on assets. We want the font size. We can go ahead and just pick this. It's doing this autocomplete, trying to make my life easier, and I'm not wanting to use the autocomplete. We want the grid to be on, which means on our plot we'll have the vertical and the horizontal lines to show where we are on the plot, the grid. Like graph paper, basically. And we want the title of the plot to be, we'll say, corporate average return on assets over the past, there's actually 12 fiscal years. 10 calendar years, but 12 fiscal years. And then we want a legend so that whoever's looking at our plot can distinguish between the line that corresponds to the median and the line that corresponds to the mean. And where do we want that legend to be on our plot? We're going to set the location, and we're going to put it in the northwest, which is what I usually do. There are other options for the location. You can put it north, south, east, west, so forth. You can even tell Matlab to do best. In fact, if you leave this argument off, if you just did this, then Matlab, if you just did this and didn't specify a location argument, like this, then Matlab would put it in the best place. But I like to specify a location and put it in the northwest corner, because usually that doesn't interfere with the plot. But you can change it accordingly depending on the context. And then we want the font size of our legend to be 12 is what I usually do. So let's plot. So this is going to plot column 8 of mean ratios by year and column 8 of median ratios by year. That's the return on assets column. And it's going to plot it, those two lines by year. By year. There's our y-axis title, our x-axis title, our legend, our title of our plot. You can see the mean return on assets by, so in the cross section in 2013 across all firms in 2013, the mean return on assets was negative 2.58. And so forth. So what you're seeing here is on average, from the means perspective, because there's two different measures of average central tendency. There's mean and median. Well, there's also mode as well. But from the means perspective, on average, firms have negative return on assets in a given year. Now, I know this mean is driven by outliers, but even if you remove those outliers, the mean would still be negative. It wouldn't be as negative, but it would be negative. And there are a lot of small firms that have negative net income, right? They have loss. They have a loss. And so those firms are dominating the data. Now, the median, though, is about 0. You can hardly distinguish. In 2013, the median was negative 0.0179966. In 2014, it was positive 0.0018837. You can hardly distinguish this orange line from 0 just because this blue line is so volatile, and Matlab automatically sets the scale and the increments and things like that. But we could go and look at the median. If we go here and look at the median, I mean, there is variability in the median. It's not 0. It varies. It just doesn't vary very much, as you can see, going over the years, across the years. And that's what's being shown in this graph here. Now, if we just plotted the median on the graph and not the mean, then you would see the variation more obviously, because Matlab would adjust the scale of the graph and the increments. And I can prove that to you here. If we just plotted the median and not the mean, we take this out right here. Just take all that out. And take this legend. And we just plot that. Now you'll see the variability more because it adjusts the scale. This is the median. Notice on the x-axis we have 2 times 10 to the minus 3, so very small numbers. So you got to be careful. Now we can change the increments of the x-axis and the bounds, and same thing. I'm sorry, the y-axis, and same thing for the x-axis. We can do that, and I can teach you how to do that in another video, but we won't do that. So let me undo that. So Control Z, undo those changes, and go back to what we had before. Notice every time you run this figure, it keeps making new figures. So if you want to get rid of all current figures that are open, you just type close all. That closes all open figures. Then you don't have to manually close them. And then we'll just run this, so we just have one figure open at a time here. Now, in academic publications, usually the journals don't allow you to submit a figure that has color on it. They want no color, black and white only. And so if you made both of these lines just black lines, and sometimes, I mean, in this context, you could distinguish this from this. But in the legend here, they both would be black, and one would say mean, the other one would say median. You wouldn't know, is this the mean or is this the mean? And so I need to show you how to make lines that are black only and that are dashed or dotted to distinguish from each other. And so let's do that. So the third argument right here after, it's optional here. We don't have to do this. If you don't specify, then Matlab just by default will make this line whatever color it wants to make this line a different color from this line. But if you specify here, we're going to specify what do we want this line to be. We want it to be, color to be black, so K stands for black. B means blue. BR means brown. R means red, so forth. But K is for black. And then we want it to be dashed. A dashed line. And then this line over here, we want it to be just a solid black line, no dashes. Now let's run this. And you see now we have no color on the graph. It's only black and white. But people can distinguish the mean from the median because we dashed the mean line and we made the median line solid. Now let's save our graph. So you come up here, hit save. Let's go in here and create a new folder. I'm going to call it figures. And you'll have access to it as well, obviously, because I'm in our shared folder. I can share this folder with you if you send me a email and ask for the link on Dropbox, or if you put in the comment section, I can share it. Let's go inside of our figures. For each of our videos, we're going to have a separate figures folder. And let's go in there and let's call this figure 1, and we'll make it a PNG file. Make it a PNG file. By default, it wants to save it as a Matlab figure file, a .fig file. But you can only open those types of files with Matlab. And we couldn't, pop that up in a PowerPoint presentation and show anybody that because it's not a PNG or a JPEG. So make it a PNG file. Save it. All right. Let's do it by industry now. So now we want to compute the mean and median of each ratio by industry. So basically we can just copy and paste all of this down here and then just change the appropriate things. So what I can do here is just change each piece. What may be easier is to take this, cutting it and putting it over here in its own separate. And then we can do a find and replace. So all, Control F. So anytime we see the word years, replace that with the word industries. Boom. So our industries matrix is going to be the unique values of R all rows column 3 though, right? Because that's where the 2-digit SIC industry column is. So now what we want to do is replace anywhere in our code where we see R all rows column 4 and like right there, like right there, like right there, and replace that with R all rows column 3. And it made the appropriate places changed. And then I guess right here we can just replace this with IND manually without using find and replace. Notice this was years as well, that changed. Down here, this changed. We'll have to do this though. And the title, corporate average return by SIC. And then on the x-axis, we don't want year, we want SIC 2-digit industry. I think everything else can stay the same. And then right here, the comments to ourselves, plot mean and median return on assets by industry. By SIC 2-digit industry. And then this won't be true necessarily anymore. But all this will be true. Oh, another thing, how do we get all the comments to be within this vertical line? I like to keep them within this vertical line. Just that's like my pet peeve or whatever. You just highlight it and push Control J. And it puts everything. And then we can just copy or cut this block of code and just put it back over here. Boom. That's how you can quickly, instead of having to type all this stuff again and just, because it's the same thing as what we did earlier, except we're doing it by industry, and then you just copy and paste the block of code over here, and then you put it over here into a separate script file, and then you do Control F and replace the portions of the code that need to be replaced. Just be careful when you do that, because it may do something that you don't intend. You have to make sure that you're exactly replacing the things you want to replace. All right, so now we can run this part of the code, all of this. We'll just run it piece by piece though. So here's our industries, two-digit industries. There are 71 of them represented in our sample time period. And by the way, there are 83 SIC two-digit industries. Only 71 are represented in our 10 calendar year sample time period. What is industry 01, 02, 21, 25? Go to the SEC website and you can figure out what actual industry that is. But we just have the industry numbers here, the codes. Let's run this. So we have the mean ratios by end here, by all 71 industries, and the median ratios by end. See all that here? Now let's plot. And you can see we plot the mean ratio, the mean return on assets by SIC two-digit industry over the past 12 fiscal years. There is one SIC two-digit industry that's a really big outlier. It's Industry 76. Its mean return on assets ratio for all the firms that are in that industry over these 12 fiscal years, across all the fiscal quarters in those 12 fiscal years. They should say years here, not industries. The reason that says industries is because when I did find and replace, it replaced everywhere where the word years was with industries. That's what I'm talking about. When you do find and replace, you got to be careful. You may replace something you did not intend to replace because you weren't thinking. There we go. So SIC two-digit industry 76 over the past 12 fiscal years. The mean return on assets across all the firm quarters in that industry over these 12 fiscal years was negative 69.452, and the median was negative 20.4828. So that obviously is an outlier, and we could go look more into detail in that. We could go look at SIC two-digit industry 76 and pull out those observations and see, well, why is the return on assets so negative on average? And if you do that for in this case, you're going to find that it's because there's a few really big outlier observations. But I'm not going to do that in this video because it just take too long. So let's delete these lines of code here. Let's save what we have. And I believe that's all I have for this video. Again, we can close. You see all the figures that are open. Close all. We'll close those. Oh, I did not save this figure. So let me run this again. Come in here. Save this in our figures folder. We'll call it figure 2. All right, we're going to close this or delete the command window, clear variables. And I'm going to show you how to exit Matlab. Make sure we've saved this. Control S. We've saved the script. Close this script, which we didn't use. And I'm going to show you how to exit Matlab very quickly. Obviously, you can do it this way, but you can also just type the command exit, and it exits Matlab. Now, if there's something that you haven't saved before you exited, then it'll let you know. It'll prompt you when you type exit and you hit enter. It'll say, do you have something you didn't save? Do you want to save it? But that's the quickest way to exit Matlab. So I hope you enjoyed this video, and I will see you on the next one.